Hi, I was looking at Cisco and ENARSI blueprint, so I decided to cover some of technologies, see if I can explain and to make things clear for those who are going to take the exam or working with this technology. So I want to talk in this video about VPN technologies, more precisely layer 3 VPN or MPLS layer 3 VPN. So as you can see in the exam topic, it says describes MPLS layer 3 VPN. So essentially you're expected to know what are the use cases for layer 3 VPN, how to deploy layer 3 VPN, and also how to troubleshoot layer 3 deployment. Okay, so to help explain this technology, I'll be using the lab that you see on the screen, so this topology, and see if I can summarize the key functions of layer 3 VPN. So layer 3 VPN is not one feature, but it is a collection of features. You have VRF Lite, you have MPLS, and you have BGP. Okay, and we're going to see in a moment how those features combining they make what we refer to as layer 3 VPN. Okay, so let's start first analyzing VRF Lite. Why do we need VRF Lite? Okay, what is the use case for that? And we're going to work with these sites. We have site 2, and I'll often refer to as branch 2. We have branch 3, we have branch 4, and we have here branch 5. So we have router 2, router 9, router 10, and router 4. And here in the middle we have the service provider network environment that will interconnect all these branches together. And we have a use case, and we need to allow the communication between site 2 with site 3 and site 4 with site 5. Okay, so this is the requirement, and this has to happen through these routers inside the service provider. Now if we were to establish dynamic routing protocol, we could also use static routes, but in a production environment, on a real use case, you wouldn't use static route depending on the requirement. But for this case, let's just use dynamic routing protocol. And we want to, for instance, advertise the network on this site, and that's 10.102.0.0.24, and we have to allow this network reach 10.10.10.0.0 network. Okay, so we would have to establish for instance OSPF between R2 and R25, and then inside the service provider environment somehow R25 would have to advertise to R26 so that R26 can advertise to R9. Okay, so far so good. Now when we look at site 4 and site 5, we have R10, and R10 has the network 10.10.10.10.0.0 in its LAN network, and we have to allow the communication with the LAN network on site 5, and this can be 10.105.0.0/24. And if you paid attention, R10 has the same subnet as R9. So what will happen when R9 and R10 advertise these networks to R26? Well, let's see. Now let me bring R9 and it's opened. See what do I have configured so far. Okay, nothing. So let's enable OSPF between R9 and R26, and I'll use OSPF area, just say 9 area 0, and I already have the IP address on the interfaces, so I'm going to advertise this one as well. And this is done. Now if we go to 26, and that should be 02 IPOSPF 9 area 0, and they should see a JCC coming up, and we're going to enable SPF on the interface facing R10, and that's 03. So let's use the process ID 10 area 0. Okay, and let's bring R10. Okay, and enable OSPF as well. So I'm just going to enable on both interfaces, so 10 area 0. And if I type the show IPOSPF interface brief, okay, it's coming up. So if I go back to R26, we can see that it already established a JCC with R9. So this means that I already have 10, what is it, 10.10.0.0 on my routing table coming from R9, and in a minute I should see the show IP OSPF interface brief from R10. Okay, so now I have R10 as well. So if I look at my routing table for 10.10.0.0, okay, I see that this network is reachable from R9, but I don't see 10.10 from 10.10.0.0 from R10. But we know it's there because R10 is advertising this network. Okay, so we know it's definitely there, but we don't see it because we can only have one subnet reachable via one of the peers. So in this case, how can we solve this problem? Because we need to advertise those networks inside the service provider environment. Now that's where VRF comes in place. With VRF, we can assign a virtual routing table for R9 and a different one for R10. So VRF stands for virtual routing forwarding, or in some situations you can also see it as a VPN routing and forwarding. So let's deploy VRF to separate or segregate a routing table for R9 and another one for R10. So I'm going to use a command IPVRF, just say branch 3, and I have to use a value to say that these networks coming from R9 belong to R9, and for that I'm going to use the feature route distinction. And so let's just say, what is the ASN? So I'm just going to use an ID to represent the networks coming from R9. Okay, so that's it. I created a VRF, and I'm going to create another VRF, another routing table for R10, and the route distinction will be 104, 104. Okay, so now I have to associate the interface towards those routers inside these VRFs. So we look at 02, so I have to say IPVRF forwarding branch 3. Okay, and now it removed the IP address from that interface, and I have to paste this again. Now the IP address was assigned to the interface, but you see here this error message VRF specified does not match. This is because the routing process now it's in a different VRF. Now it's what is called as global routing table. So we have to delete that OSPF process. You see here router OSPF 9. So it is sitting in global routing table. So we have to remove from global routing table and create another, or again, this routing process inside VRF for branch 3. So I'm going to delete that process and back to interface 2, IP OSPF 9, area 0. So I'm going to do the same for router 10. So let me just assign a different router ID. Yes, no problem. So if I look again, OSPF, you can see that now the process router OSPF 9, okay, it's inside VRF branch 3. So let me just do the same for E03. So that's one facing R10. So IP VRF branch forwarding branch 4, and IP address was removed, and I have to delete the routing process 10. So no router OSPF 10. Back to interface, IP OSPF 10, area 0. Okay, so OSPF not until the IP. Okay, I didn't paste the IP address, so let me do this again and double check. Okay, so that's it. So now we have a different routing table for branch 3 and a different one for branch 10. So let's confirm that. Do show IP route VRF branch 3, and I can see 10 10 10 10 coming from R9. That's great. And if I look at branch 4, 10 10 10, I don't see you. Let's check if OSPF adjacency is established. So it's coming up. You can see it already detected R10, so it's in wait state. Okay, so okay, now it's operational. Now let's look, and I can see 10 10 10 coming from R10 and 10 10 10 coming from R9. So we solved the problem. So that's what VRF was used for, to separate the routing tables between two customers or two different peers. Now we solved one problem, but now we have another one. You see, whenever we create a VRF, we are placing a different routing table, and we have to assign the interfaces that will be part of this routing table in all the routers. Essentially, this means that if we want to extend the communication between these VRF on R26, we would have to configure the same VRF in R22, and we would have to assign an interface to that VRF. We could use 00, or we could use sub-interfaces. But if we do that for each VRF that we create, you can see that this is not a very scalable solution. And we only have 1, 2, 3, 4 routers where we would have to configure this VRF. But imagine if we had 100 VRFs or 100 routers. So that's not a very scalable solution. So we need a way to scale these VPN assignments to the customers. Okay, before talking about the solution, we also have one requirement or a problem. We are advertising the network from the customers. So for instance, we have 10102 being advertised on R26. So let me bring R26 routing table to show IP route OSPF. So let's take a look at 10. Where do I have from R2? I don't see nothing coming from R2. Let me just double check that R2. Okay, so not yet, but let me confirm the interface. Okay, I have. So let me enable IP OSPF. I'm going to use process ID 0, process ID 2, area 0. So I should establish an OSPF adjacency between R2 and R25. And it's in wait status. It didn't receive any hello packet from R25. It means that I didn't enable yet on that interface OSPF process. So area 0. Okay, so now Okay, so we can see that R2 now received the hello packet, so they're going to establish the adjacency in a minute. So what is the problem that I'm trying to show here? So we have R2 advertising its networks to the service provider router, okay? And that's going to be installed in R25 routing table. Also, we see those networks that belong to the service provider environment. Essentially, we have the networks from the customers and the service provider all in the same routing table. And what is the problem? Well, we only showing one router, but imagine if we had 10 routers. Imagine if this customer had 1000 networks being advertised into the service provider network. Or even worse, imagine if the customer was using the same network addresses as the service provider. We would have a problem, okay? So we need a solution to advertise the customer's networks inside the service provider environment without affecting the service provider network, or even prevent the networks from the service provider from being advertised into the customer's devices. Okay, it's like we needed a tunnel across the service provider environment. So that's where MPLS comes into the picture. With MPLS, we can establish a tunnel across the service provider environment, and it would look like R2 and R9 were directly connected. They wouldn't see directly each other, but the networks being advertised wouldn't be visible from those devices here in the middle, and would only be seen by R25 and R26. And we already saw that by using VRF, we are creating small VPNs on the routers. So we are segregating the networks between the customers and also the service provider. Okay, so VRF allow us to create this segregation. MPLS will allow us to build a tunnel across the customers without advertising the customers' networks inside the service provider environment. And now we need one more piece into the puzzle: how we're going to advertise those networks across different peers inside the service provider network. So that's where BGP comes in the picture. So BGP, it was improved actually to support this type of requirement, and this is referred to as multi-protocol BGP. You see, when we are using VRFs on these routers 25 and 26, and these are referred to as provider edge devices, so or PE, because they connect to the service provider environment and the customer devices. As for these devices, these routers, they are referred to as CE, or customer equipment, customer edge devices, depending how you want to call it. Okay, so we have those devices here in the middle. They are referred to as provider devices because they don't connect to any customer device. So with BGP, we are advertising the networks inside the VRF, inside the VPNs. So essentially, let's say we're going to advertise IPv4 networks. So we would use VPN v4, okay, to advertise those networks from the customers dynamically inside the service provider environment. So those are the three features that make layer 3 VPN. Okay, so now let's combine all of these and see if we can meet the requirement. Now we already have VRF deployed on R26, so we have to do the same on R25. we go to 25, and I'm going to create another VRF, and I'll say that the ID for this VRF is going to be 102. So this ID is route distinction. Okay, and I'm going at the interface level. Okay, I have to remove this router OSPF process. Now I'm going to assign this interface inside the VRF. So that's going to be actually branch 2, and just going to copy and paste this. Okay, done. So the adjacency will be recovered between R25 and R2. So it's done. So let's just double check. Do show IP route VRF branch 2, and we can see that 10.102 it's being advertised, and it's inside the VRF for site 2. Now I'm going to do the same on R23, and I believe I already have it here. Yeah. So I'm going to create VRF route distinction. Here we'll use 105, and take a look at the interface. I don't have. Is it the right interface? No, it's a 01. Okay, so IP VRF branch 5. Let me just copy this. Oh no, that's wrong. IP VRF forwarding branch 5. Okay, now it was correct. So now I'm going to enable the OSPF process. IP OSPF, let's say 5 area 0. And let me bring R4. Do I have it? Not yet. Okay, let's bring R4. So R4, you see my local interface. It's going to be 01 IP OSPF 5 area 0. Okay, so this is done. Now, inside the VRF, inside the service provider, we just created VRF. Now we need to build the tunnel, and we're going to deploy MPLS. So to enable MPLS dynamically, we can use a shortcut inside the routing process, but here let me just enable at the interface, because we only need it on one interface. So it's going to be MPLS IP. So now let's bring R21. So here, because I have multiple interfaces, I'm just going to enable MPLS LDP auto config dynamically. So you establish an MPLS adjacency with R23. Going to do the same for R22. So router OSPF1 MPLS LDP auto, and should see adjacency with R21. So now let me bring R25, and I'm going to enable at the interface, and now 26, the same thing, MPLS IP. Okay, so the tunnel is established. It's okay, which means that the customer networks, they will be swapped across the service provider environment. I won't go deeper into MPLS LDP, because I want to keep these short as possible, but also clear, so you guys can understand how this works. So we have MPLS. Now we need BGP or MP BGP. So to make this process faster, I'll use Notepad just to make the configuration, and then I'm just going to update and paste directly on the devices. So first let's start with PE23, and so that's going to start with the BGP configuration. So I'll use the ASN 64512, and I don't want to enable default address family IPv4. I want to only enable VPN v4 address family. So my neighbor will be 26. It's going to be an IBGP neighbor, so it means that the ASN will be the same, and I want to establish the BGP session from the loopback interface. Okay, So the VPN v4 have to be enabled for 26. I want to activate, and also I want to use these attributes send community extended, and I'm going to explain these in a moment. Now, as we are using VRF branch 5, so we have to inject the networks that are in OSPF process into BGP. So we're going to redistribute the networks from OSPF process number 5, and we also have to advertise the networks that will come from R26 in BGP to be redistributed into OSPF. So we go to OSPF routing process, and I'm going to redistribute BGP 64512 subnets. Now, one piece is missing here is I mentioned about these attributes and community extended. So at the BGP process, we have to say to which VPN those prefixes will be installed, or from which VPNs or VRF we're going to extract the networks, or we're going to import or export. Now, the way we do that is by going into VRF configuration mode, and we use the command route target. Now, for instance, on site 5, we want to export the networks from site 5. So we're going to say route target export the networks from site 5. So this is just the ID that I'll be using to reference the networks coming from site 5. And now I have to say, okay, which network should I install, should I import into branch 5 VPN? And I'm going to use the route target import, and let's say that the networks coming from site 4, they will have the ID 104, and that should do it. Okay, so we are exporting the networks from site 5, and we are importing the networks from site 4. Okay, so that should do it. So let's take a look. IPVRF, then we enable BGP, update source, enable VPN v4, sending route target as an extended community attribute, injecting OSPF networks into BGP, and injecting BGP into OSPF. Now let's paste this into R23. Okay, done. And we're going to do the same on PE26. Actually, let's start first with 25, because there isn't much to change there. So on 25 we have VRF for branch 2, and let's say that we're going to export using the ID 102. This could be any number. I'm just using this to make it easier to identify. And we're going to import the networks coming from site 3, so we use the ID 103. As for BGP, we won't establish a JCC with 23, only between 25 and 26, so we leave it as it is. As for VRF, that's going to be branch 2, OSPF process will be 2, and so you have to change here as well. So that's it. We're going to copy and paste this into R25 that I don't have here. Okay, so let's open terminal console for R25, and let me increase the size of the letter. So appearance, let's increase to 14, and session, let's save it as R25 and apply. Awesome. Now, okay, paste, and we're going to finally do the same for PE26. So here on PE26 we have 2 VRFs, so let's begin with VRF 3. We're going to just change here the names. Okay, we're going to import 102 networks, and we're going to export 103. As for BGP, we'll establish adjacency with 25 and 23. So let me paste these here. So here is going to be 23, 23, and we have to enable also those neighbors. So first will be, can be 23, and let me copy this and paste, and let's type 25, 25. As for VRF, we have two VRFs on R26. So first is branch 3 VRF. We're using OSPF process number 3, and we have another VRF, and that's VRF 4. We're using process ID, I believe that's 10. So we have to inject BGP networks into OSPF process number 3 and number 4. Actually number 10. Let me double check. That's what I have. I can remember. So let me bring R26 and let me change the appearance, font size 14. Just make it visible. 26. Let's save and apply. Now to show VRF, RSPF 9, and the other one 10. Yeah, that's right, that's 10. So branch 4 OSPF process ID is 10. Okay, so looks like everything is in place. So let me just copy, and it's missing here VRF for site 4. So I'm going to change here. I'm going to import the networks coming from site 5 and going to export the networks from site 4. So now everything looks to be in place. So we're going to copy all of these and paste into R26. So it's complaining there, failed to assign a router ID. I wonder if it's related to router 3, OSPF process number 3 or the number 10. So just show IP OSPF interface brief. So it looks like it's okay. Just show IP route. Okay, let me see. Number 3. Okay, so this is site 3. Okay, so let's assign a router ID. So router SPF 3. Is it 3? Process ID number 3. I don't have process ID number 3. So that was my mistake actually. Yeah, that's OSPF number 9. Okay, that's why it's complaining. Okay, so it's going to be 9. So it's complaining because it doesn't exist. So I'm just going to copy and paste. Okay, yeah, now it shouldn't complain. And I'll just remove OSPF number 3, doesn't exist, and show IP OSPF interface brief. So I have 10 and 9. Okay, and everything should be okay now. Now let's see if the BGP adjacency are established successfully. So let's start with branch 3, and we can see the network coming from site 3 and the networks coming from site 2 being advertised from R25. Now we'll take a look at branch 4, and we should see the same for site 5 LAN network, and we also have the LAN network from site 4. Now let's confirm this on R25 as well. Show BGP VPN v4 unicast VRF branch 2. Okay, we can see 10 10 10 coming from site 3, and I'm advertising 10 102. Now finally let's confirm this also on R23. Do show BGP VPN v4 unicast VRF branch 5, and we can see 10 10 0 0 coming from R26, and I'm advertising 10.105. Okay, so from the control plane perspective, everything seems to be working as it's supposed to. It doesn't mean that at the data plane everything is working. So now let's bring some hosts so we can test reachability between let's say host 29 to host 31. So can I ping? Let me increase the size as well. Appearance and 14. Okay, and that's going to be our 29. And I already have. Okay, so let's cancel this. I already have 29. Okay. So can I ping 10, 10, 0? That should be 31. I can. What about trace route? 10, 10, 0, 31. And it's working. We can see that I reach R2, then I got to 25, and this is inside the service provider environment. Then it was delivered to R9 and it reached its destination. Now let's do another test from another host. Let's see, do we have 32 or 35? Just see if I have another session here ready. 32, and I don't have, but I have 35. Okay, awesome. Now can I ping 105.32? I can. What about trace route? 10, 105 or 32? And it's working as it's supposed to. We see that we reach our default gateway PE26. This is inside the service provider. We see here the labels, and then is delivered to R4 and it reach its destination. So that's it, layer 3 VPN. I hope that it was very easy to understand. My recommendation, if you want to go deeper into these technologies, is to study them one at a time. Starts first with VRF, then MPLS, and then BGP in any order, and then you'll see how easy it is to deploy, configure, troubleshoot layer 3 VPN. So I hope you guys enjoyed this video, and until the next time, adios.